So chapter 9 is about counting and probability. Although you may have learned about a little bit about the probability, but maybe we can skip this part. This is about the junior form mathematics. So a sample space is a set of all possible outcomes, okay? An event is just a subset of the simple. So you know the definition of probability, that's it. And then we'll skip it first. And
Okay.
okay, so this I think you know it from primary school already. This one.
Yeah.
So we remind by ourselves, what does mean by inclusive? That means it includes the m and n. And then when you need to plus one, you count it by yourself. You will know the answer. Then let's go to next session. Possibility tree and multiplication rule. I think also you know how to draw this probability tree in junior form mathematics, and then you just can't you know how to do it. I think so. May I just skip it? Then let's go on to next part about counting the elements of this joint set and additional rule. But let me have a look first, okay? Why there's no n factorial, NCR, something like that? Okay, just forget it first here. Actually, I don't need to teach this to you. This is so easy. So actually, I don't need to. I think you know it by yourself already. So let's keep it, and then let's go to something that you haven't learned. Now this one. Now this one has also another name for it. It can also call the De Morgan's law. So let me prove it to you. Wait, I need to connect to the pen. My drawing pad. So how can we prove this one? Actually, it's quite easy if we can draw the Venn diagram. So let me draw the Venn diagram first. So there are two events, A and B, okay? So what does mean by A union B? A union B is the area that is highlighted by, sorry, this one. So it's highlighted here. You can see A and B has some intersection. So
Yeah.
and then for union, that means, okay, the highlighted area. So n is the number of the A and B, okay? N is number of something, that means. So if A and B is the number of elements in the set A and B equal to NA plus NB minus. Now why you need to minus this one? Let me draw this area. So this is the area that they overlap, okay? And then why they need to minus this area or this number? Because if you count it A union B, you just want to count this you just want to count the numbers in this area. And then NA is this one, NB is this one. Actually, you double count the area in the red region. So you need to minus 1 times the overlap area. Then you get this number. And obviously, you can rewrite the formula like this one. This is what you may need to remember, okay? So let's have a look at one of the examples. So let's say this one. So how many integers from 1 to 1000 are the multiple of 3 or multiple of 5? So how can we make use of this theorem to do this question? So what we would like to do, okay, it's not difficult for us to get the multiple, the number of integer that are multiple of 3. So it's starting from 3, 6, 9, up to 999, okay? So, and then how many numbers are here? Hello?
We have 300.
No.
No, no, so not 300. Like there are three numbers which are divisible in every 10. Sorry, so then it's like uh,
How many numbers are in 369 up to 999?
333.
Yeah, 333. So how can we look at this easier? We just divide every number by 3. Okay. Then you know that there are 333 integers in between. So you can do it in a similar way, okay? So how many integers are in 5, 10, 15, up to 1000? You divide every number by 5, you get 200, okay? So does the answer, is the answer 333 plus 200?
no,
Why not?
because there may be some overlaps. Like
There are overlaps. So what does mean by overlaps? Just like the number
900 or
15,
15.
15, 900, something like that. They are also the multiple of 3 and 5. So you double count those numbers. So what are the properties of those numbers?
They're divisible by 15.
Yeah, so you can say they are the multiples of 15. So let's just like this one, okay? They let A be the integer, that is multiple of 3. B be the integer, that is multiple of 5. So, and then we need to make use of that formula. So if we want to find the union, okay? So that is this one, okay? Union means this A or B, okay? For the intersection, okay? A intercept B, that means A and B, they are both multiples of 3 and 5. That means they are multiple of 15. So we need to, if we want to count this number, so how can we do that? We need to make use of the formula. So that's NA plus NB, then minus NA intercept B. So how can we find the number of multiples of 15? So how many are the number here? Okay?
Uh, 6,
6?
I think.
Only 6?
Yeah, because like 15, 6 is 19 or something like that.
So if 15 are 30 are,
Wait. No. 60,
66.
60.
okay? So if you divide every number by 15, then you get 1, 2, up to 300. So up to 60. So the number is 60. So that's your final answer, okay? That is 473. So there are 473 numbers of integers, which are the multiple of 3 or multiple of 5. Okay.
Sir, but there are 915 and 930 and more, aren't there?
Yeah. This is a trap for you. You don't get the in the trap, okay? So the largest multiple of 15 should be 990. So it should be 66. 487, okay? 467, is it? Let's check the answer, okay? Yeah, okay. So the answer is 467. So how about if they are neither this multiple? So what you need to do is 1000 minus this number, okay? Simple, okay? This is a basic question for you already. They will not be appear in the combination, of course. So and then even for those very complicated cases, you may draw the Venn diagram and then which can help you to find the numbers. So let's go on to the next session. We are not going to do, so you may do the questions by yourself, but let's talk about the pigeonhole theorem. Pigeonhole theorem is so simple actually, but you may not know how to apply the pigeonhole theorem easily. So let's have a look at this one. I think it's not easy to understand this statement, okay? So let me turn it into a more simple. So let's say there's n elements put into m bags where n is greater than m. And there is a bag which contains at least 2 elements. So this is a more simple statement of the pigeonhole principle. I think you should understand this one, is it?
Yeah.
So actually, this statement, I think even a primary school student can understand this one. But the application of the pigeonhole principle is not that easy. But we're not going deep into this part, okay? We can talk about this later on, okay? But you may have a look it by yourself. You may have a look by yourself. Then let's go on to the next part about the combination. So this is the core parts that I want to teach today. So this is about actually you may have learned it already, NCR and NPR. But first of all, let's go on to talk about the factorial. Have you learned about the factorial? I think yes.
Yeah.
So for factorial, that is n factorial. That means n times n minus 1 times up to 1. 1 factorial and then 0 factorial is defined to be 1. That's it. So and then let's go on to, so what is the meaning of the factorial? So let's say there's n person. You know this symbol, I think. You know this character.
Yeah. Run.
There are m people, okay? There are maybe to be more generalized, okay? There are n different objects that are put into n different boxes. And one box, one object in one box, okay? In one box. So n factorial means the number of combination or number of choices that you can put. Okay, number of choices. So how can we understand this one? So let's say there are n boxes. So for the first box, you have n choices because you haven't put any objects inside the box yet. So that means you can choose any one of these n different objects. So after you have put one object in this box, and then for the second box, you can only choose n minus one different objects. Okay. So you need to, the number of choices is n times n minus one, and then times n minus two, and up to one. Okay. For the last box, you have only one object left. That means that you have no choice. You can only put that object in this box. And then you simplify it, and you give you the n factorial. So that's the number of different choices that you can put n objects into n boxes. Okay. If no question, and then let's go to have a look at what does mean by NCR. So NCR, it means the number of choices that you can put n objects, n different objects into R boxes. But n should be larger or equal to R. Eh? No. No, this is NPR, it's not NCR. No, so sorry, let me change it, okay? But let me have a look, where is the NPR? It's easier for me to talk about the NPR first. Then never mind, okay? You just copy it down by yourself, okay? I don't know where it is. So for NPR, right, the definition is like that, like this one. So let's derive the this value, okay, by this definition. So we consider there are R boxes. Have you learned NPR in mathematics? No? Yes? No? No? Hello? Hello? No. So for the first box, you have...
Yes,
Yes?
I think we learned it in a map. I don't know.
Okay. For the first box, you have n choices, okay? For the second box, you have n minus one choices. And then, how about the last box? How many choices how many number of choices you can put in?
One.
No.
Wait, last box.
Yeah.
N.
No.
More than one?
La. There are only R boxes in here. But you have n objects. N is greater or equal to R.
So R.
No. What is R?
N minus R.
No. So how many objects have you put in before these boxes?
R minus 1.
So you have put R minus one objects already. So how many objects left? How many?
N minus R minus 1.
So that is n minus R minus one, okay? So that is n minus R plus one. Okay, all of you should improve how you count the number. Okay, so that means that the NPR can be written as n times n minus 1 times n minus 2 up to n minus r plus 1. But it's so clumsy to write it like that. This actually, how can we write it there? How can we simplify it there? So let me write it down. Okay, n minus r plus 1 then times n minus r and then up to what there? And then up to 1 minus, is it? So then how can we
Yeah.
find even more there? So you can simplify it as n factorial. Oh, so sorry, not multiple to 1. So you can write, okay, sorry, let me erase it again. Sorry, let me erase it again. So you know how this is, how to derive this one. So let me simplify it more. So then you can multiple n minus r minus 1 and up to 1, and then divide by the terms that you multiply. Okay, can you see it? So I multiple the same thing on the denominator and numerator. Okay, because I want to try to simplify this formula. So in the numerator right now, it is a n factorial. It is the n factorial. For the denominator right now, it is n minus r factorial. Okay.
Yeah.
So this is the definition of NPR. So you can capture the screen, okay? I'll erase it now. Then let's go on to talk about the NCR. Okay. No question, then I will erase the screen now. So, and then let's go on to talk about, let's give you one example, okay? Let's say there are 14 students. Say they want to line up, okay? So they want to line up a queue. So how many different ways you can find? So the number of different ways to line up is 14 factorial, okay? The question may not give you the term boxes, okay? But you know when they line up, that means they are put into 14 different boxes, just like this one. Okay, so the number of different ways to line up should be 14 factorial. Any question here? No.
No.
So let's do a similar question, okay? If there are 14 students that they would write, let's say 5 students are chosen from, sorry, 7 students are chosen from the 14 students, and then they will want to line up a queue. Those 7 students, they will want to line up a queue. So what is the number of different ways to line up that? It's just like the definition of NPR. So it should be 4.
It should be 14 times 13 times 12 times, like until before 7.
Yeah, or you simply put it like this one, okay? 14P7. 14P7. Do you understand this one?
Yes.
So that means that because why do you write it like this instead of like 14 times 13? Because you can type this one directly in your calculator and get the answer. Okay.
Yeah, but won't in the competition we would have to write like numerical values?
Yeah, you need to write down the exact value.
Okay.
So let me give you one more challenge, okay? So there are 14 students. So they want to line up 2 queues, okay? That means two rows, okay? The student here, okay? And each one, which queue has each queue has 7 students. What are the different number of ways to line up?
Line up in 2 lines and 7 students. Okay.
If you may send me your answer in the chat, or then let's go on, or otherwise let's go on. Any question? So what's your
Wait, the answer is n.
So actually, the answer should be still 14 factorial. I make a fake question for you actually. So why is still 14 factorial? Because they line up into 2 queues. That means there are still 14 boxes, different boxes. Okay. So the answer should be still 14 factorial. But
This,
Hmm?
but second, like one of the student from like if it's different possibilities, like this student can also be like here. This student can be like here.
So if you count the 14 factorial, that means it count all the possibility already.
Okay.
So if you want to, if you think that the answer should be quite related to this one, actually fine. So actually we can still using this result. So for the first line, there are P147, 14P7 choices, okay? And then how about the next line? Now you have already chosen 7 students in the first row already. So that means there are only 7 students left. So they want to queue up in a line. So that means it has 7 factorial choices here. So you multiply they together, and then you try to simplify it. Okay. So this is 14 minus 7 factorial times 7 factorial. So the final answer should be still 14 factorial. Okay. If no question, then let's go on.
No question.
So then let's go on to have a look what does mean by NCR. So you can have a look here. So this is NCR, right? They are not about the lineup. So this is about the grouping. So let's say if they are NCR equal to number of combination. That's it. So NCR is the number of combination or the number of choices in which n people are chosen to form a group of R people. Of course, n should be larger or equal to R. So let's have a look at some simple characteristic of this NCR. So how about NCN? What should be the answer for NCN?
1.
1. Yeah. Yeah, because you are chosen, you are just n people have form a group of n people. So it means that.
Yeah.
So what is the difference between the group and line or the boxes? In terms of group A B C or BAC or BCA they are all considered to be in the same choice. Okay. That means that the order does not matter. The order does not matter in a group. So that means if in your group they have A, B, C, it doesn't matter the order. But if they are queuing up in a line or they are putting into different boxes, the ordering is matter. So and then, so let's try to derive the NCR. Okay, the NCR, the value of NCR. So then how can we derive the NCR? So we can start this from the NPR. So we know that the definition of NPR is n factorial divided by n minus r factorial. And then you know the meaning of NPR is choosing R people from n people to queue up a line. So if it is the NPR, the ordering is matter. The ordering matters. So let's say there are R people here. You are choosing them to form a line. So if right now for NCR, the ordering does not matter. So what can we do咧? So let's say there are people. How many different ways when they line up咧? Our people line up here. So let's say this one is A, B, C, D, okay? It can't as one choice in NPR. So they can also be N, C, B, D, okay? It can't as another choice in NPR. But they both count as the same choice in NCR. So what we can do is divide by the number of choices that our people can line up in, queue up in a line. So what we do is NCR can be defined as NPR divided by the choices that our people can form in a line of our people. That is our factorial. So that gives you the definition of NCR. I think it may be quite difficult to understand right now. Do you understand? Or
Yeah.
yeah, I know it may be quite difficult to understand. So then let's have a look at another definition that you may already familiar with already. So this is about the binomial expansion. I think you've seen NCR in binomial expansion, is it?
Yeah.
So let's understand the binomial expansion using the concept of combination. So you know for A plus B to power n, it's a summation of NCR, A to power R low, and then B to power n minus R. R starting from 0 to n. Okay, this is what you have learned. Do you use this symbol to represent the expansion? No? Yes, no?
Summation, like we haven't learned about summation, but we
Whatever.
learned in FPM.
No, it doesn't matter, okay? Doesn't matter, okay? So what you say for NCR, you say NCR is the coefficient of the term A to power R and then B to power n minus R, okay? At least you know this one, I think. Well, let me give you one example in terms of the numbers. So let's say it's 1 plus x to power 7. So you know that it should be written as C70, actually this is 1, times 1 to power 7, plus C71, 1 to the power 6 times x to power 1, okay? So this is what I mean here, actually. Okay, no question. So then how can we understand this one using the concept of combination? So let's say I write the A plus B to power n in form of this one. So there are n terms here. So that is equal to A plus B to power n. Maybe let me use some number to explain this one. Maybe that will be easier. So let me cancel out this. So let's say to power 8. So there are 8 terms here. So let's say if you want to find the coefficient of A to power 3 times B to power 5. Okay. So how can you understand? So how do you choose a to power, sorry, how can you find the coefficient? By using counting method. So the terms a to power 3 times b to power 5, that means,
Like if we consider, if you like considering from ascending order of power of a, then we can just do like 8 8c3 to get the coefficient.
I know. Yeah, but I want to use the combination concept to explain this one. 1, 2, 3, 4, 5. Wait for me. So let me draw 8 terms here, okay? So how can you get a term that is a to power 3 times b to power 5? So you can choose the a in this 3, and you can choose the b in this 3, in these 5 terms, okay? So and then if you multiply them together, then you will get, so a times a times a times b times b times b times b times b, then you get one term that is a to power 3 times b to power 5, okay? But you can, for the first brackets, actually you can choose b instead of a. So you can get a, you can choose b, okay, instead of a. So you can choose like these 3 a's, and then the 5 b's are these 5 b's. Okay? So the 5 b's are these 5 b's, okay? So you can get another term that is a to power 3 times b to power 5. So actually, that means that the coefficient of a to power 3 times b to power 5 are the number of choices. Actually, it means the number of choices that you choose. That you choose 3 A's and you choose 3 A and 5 B from these 8 terms. Understand this one?
No.
So then how do you, so let me simplify the case into 3, okay? A plus B to power 3. So how can you get a term that is A squared times B? So you can, this A times this A times this B, okay? Or this A,
Yeah.
this B times this A. Or this B times this A times this A.
Oh, okay.
So that means there are 3 different choices, okay? For you. So that means actually the coefficient should be 3 here. The coefficient of A squared times 3 is 3. But similarly, in this case, it's more complicated actually, of course. So it's A to power 3 times B to power 5. So the coefficient is just mean the choices that you can choose 3 A's and 5 B's from these 8 terms. But if you understand furthermore, you know that actually you don't need to choose the B if you have chosen the 3 A's. Because there are only 8 terms. The 5 terms left, you need to you can only choose the B. So that means if you have chosen the 3 A's already, then you don't need to say that you need to choose the 5 B's because there are only 5 B's left. And then so that means that the actually the coefficient should mean that the choices that you choose 3 A's from 8 terms. So actually that means that it should be 8C3. Understand or not?
Yes, I understand now.
So did we put that in the calculator, HC3, and then we'll get the answer?
You can get the answer,
Okay.
but you should know the meaning of this one. If no question, then let's go on now.
We can go on, I don't mind.
So actually, if you consider like that, so actually you can choose 5 Bs instead of 3 As. If you have chosen 5 Bs, that means that the only 3 terms left, you need to choose A. So actually, if you think carefully, actually HC3 that should be equal to HC5.
Yeah.
Okay, I've captured the screen, and then let's go on. How do you learn the NCL? You start the NCL from the Pascal triangle. Okay. Have you learned this one?
Yeah.
You know why the Pascal triangle can give you the coefficient?
I don't know the math behind it, but like I know it has like many uh codes, many like numbers which are like triangular numbers and cubic numbers and stuff like that.
So if you want to understand, actually how we get 1331 is starting from 121 plus 121. I don't know how to explain easily. And then you get 1331. Or you can understand by using this identity. For the identity of NCR, there are a few more. Few of it are NCR equal to NC n minus R. That's the one that we talked about just before. We talked about these two are equal. So this is one identity. So another identity for it is NC. Today's homework is for you to prove these two identity. If you can understand this one, why these two numbers add up to be 2 here, or why these two numbers add up to be the number here, because they use this identity. So you can try to prove this identity by yourself. So just a hint for you. So how do you prove this identity? You're just starting from the definition of NCR. It seems so complicated, but it's not difficult to prove it. So after we have talking about the NCR and NPR, so let's have some, you can actually do the exercise here. Exercise set 9.5 to see if you are familiar with it or not. There are more different, there are several more different tricks here. So maybe let's go on to familiar with the NCR, NPR, and N factorial by using this example. Let me wait for me. Wait, I'm searching the terms. If you can do this, and then that means you're very familiar with. Okay. Poker hand ranking. Okay, and then let's have a look at this one. Now, I'm not teaching you to gambling, okay? But we are using this one to learn mathematics. File type. Yeah. Okay, this one. Can you see my screen? Hello.
Yeah.
So this is one game of the card game. So do you know how to play this card game?
No.
So at least you should know that in a card, for the card there are 52 different cards, excluding the joker. So in Chinese we call it, in Cantonese we call it the big two. In English we call it the big two. In English, I think they have some special name for it. You may search the poker hand ranking, okay? And you can find this one. How about the others? Do you know how to play this one? No? You all don't know how to play? Kim, how about you? Do you know how to play this one?
Actually, I do.
Yeah, okay. Jasmine, no?
No.
Oh, because maybe this is some Asian game. Then,
But sir, like we are Asians too.
I mean East Asian, okay? So, and then 52 cards, and then you know that there are 1, 2, 3, 4, up to 10, okay? And then J, Q, King, okay? And that's it. And each number has 4 cards. I think you know these all, is it? The 4 card means different, what, different, how can I say this one? So there are different 4 types, okay? One is the diamond. One is the heart. One is the, how is it called? How is it called?
Spade.
Spade, and then the one thing that is I don't know how to call, okay? So there are 4 different types. So we are going to count the number of different choices. So let's say if you are take 5 cards from 52 different cards. So what are the number of choices? Royal Flush. So we want to find the number of choices. Maybe if you like that, you can do it by yourself at home, okay? You can send me your solution. But if you don't understand this one, you can search the Wikipedia to see. I think they give you the definition. Poker hand. Let me see. Let me search. Poker hand Wikipedia. Yeah, they list out already. But they have different terms. So and then I send you the link in the group, in the WhatsApp group, and then so today's homework, it will be a very, very, very difficult homework actually. So if you can get all them correct, that means that you are very good at poker. You are very good at gambling. So today's homework, okay. If you like that, you can do the textbook, chapter 9.6. Yeah. No. Sorry, chapter 9.5 exercise. You just choose those difficult questions, okay? And then also the homework is you find a number of choices in different kind of the poker hand. So you can refer to the Wikipedia. They give you the definition instead. Okay. So let's end the lesson today now, okay? Then see you on Friday. So we will talk about the solution on Friday. But you can send me your solution. Bye bye.
Okay, bye.